My name is Jon, here to talk about test-driven development. But the first thing I want to do is get a picture for my wife, just to prove that I am not somewhere bad, doing something bad. Everybody say hello. Oh, let me try again with HDR. I'm sorry. One more time. Hello. Okay. Thank you very much. So let's talk about test-driven development. If there are folks here who are not iOS engineers, if you don't know Objective-C, I apologize in advance for some of the code examples. I'm not going to explain Objective-C syntax, but the principles are the same. I think you will be able to apply them without much problem. And one drink, and I'm good. So let me explain, actually, let me first find out, how many of you have ever written a unit test? Oh my goodness, that's almost everybody. Maybe it is everybody. How many of you then have written a unit test first before? Okay, still a good number of you. How many of you maybe have tried test-driven development with something simple, code kata, like perhaps the bowling game or Fizbin, and then you didn't know how to apply it to the real world? Anybody who's... Okay. So my goal is to try to bridge the gap between sort of... It's easy to start in a toy program, right, that doesn't do very much. The question is, how do we do test-driven development in a real-world app? So I am going to assume a little bit of knowledge of test-driven development, but just one slide to get us going. Because if I do recommend that if you want to start with TDD, that you do start with a code kata. It's just because you should simplify as much as you can just to learn the basic mechanics. And these are the basic mechanics, these 3 steps that continually iterate. So just quick review. Step 1 is to start by writing a test, writing a unit test, and it must fail. It must fail because then step 2 is to do the simplest thing in your production code to make it pass. And by simplest, I mean it can be dumb. I mean it can be a hard-coded value that you're just returning back. The goal of doing that change is to transition from failing to passing. By doing that, you are proving to yourself that everything is hooked up correctly, that your test code and your production code are actually talking the way you want it to. Once that's in place, then the real magic of TDD is in the bottom circle, refactoring. It is that is the magic sauce. It's what TDD enables, and this is why I don't consider TDD to be a testing discipline. It is a coding discipline. It enables me to refactor boldly, to make wild changes to my code. I can rewrite stuff if I want to, because I've got tests that will check that it still does what I promised. So one challenge, though, is often you will hear that unit testing is not suitable for 2 things in particular, UI and networking, or anything that's asynchronous. Over there you see a screenshot of the eBay fashion app. That's sort of my day job, is to work at eBay on their iOS apps. And on the fashion app, I did, among other things, the sales portion, featuring special things, and of course you can tap into any of those sales and buy wonderful things. I don't know about your apps, but my apps conceptually are not difficult. It's just connecting the user to some eBay services, right? And so the job of my app is to do networking and UI. Okay? So it's pretty much all I do. And I do test-driven development. Everything you see there was done with TDD. So I'm here to say, when people say that TDD is not possible or not good for UI or networking, I don't know what they're talking about. Maybe I just never bothered to listen. It hasn't stopped me, and I don't think it should stop you either. So this is this is where I would like to go as far as like what is a real-world example. By the end, I hope to show you an example of doing some unit testing for networking calls. So let's talk about unit tests, because that is the maybe the hardest part of TDD. Is you sit down and you say, okay, I need to write a test. What do you do? It turns out there are 3 types of unit tests. I'm going to introduce some terminology here that are standard terms, and it's I'm not here to show off terminology. I'm here to provide you with some vocabulary, kind of like when design patterns first showed up. Suddenly I could say factory, and you would know what I am talking about. The same is true of these terms. So there are 3 basic types of unit tests. There is the return value test, the state test, and then the name of the third one I call here interaction tests. Another term that you will see is behavior tests. So let's get into each of these. And a unit test has 3 sections to it, called the 3 A's. This way: arrange, act, and assert. Arrange is basically setting up things so that something is in some sort of frozen shape ready to be called, and then you call it and it will do something, and then you test to see if it did the right thing. Okay? So for a return value, this is very simple. This is if you just call a method that returns a value, a function basically. In which case the test is fairly straightforward. You just set up your object, and then you call the method that returns a value, and then the test can simply take the actual value that was returned and compare it to an expected value, pass or fail. Okay? That should be no problem. I think any of you are capable of doing that right now, and you should. Basically, don't let the scary parts of TDD that I'll go into stop you from doing the simplest things. There's plenty, especially if you follow Chris Eidoff's advice about slimming things down and making classes smaller. You will find that they become more testable. So this, in graphical form, it looks like this. Here's another term I'll introduce you to, the SUT. This stands for System Under Test. It could be one object. It could be a few objects that are connected together. It really doesn't matter. All that matters is that the test can call the SUT and get a value back, and then the test can do what it does. Okay? Straightforward. I don't think there will be any problems with that. Let's move on to the state test. In the state test, it starts the same way. You set up your object, then you call a method, but maybe the method doesn't return a value. Maybe the method doesn't return a value, or maybe it does, but you're interested in some other side effect because you're dealing with an object and it's going to change its state in some way. So the test then can simply query the object for its new state and check that it should be as it should. So it looks like this. First, the test calls the SUT. It invokes the method that you're really interested in, the one that's supposed to make some sort of change to the state, and then it will make a second call to query that state. It may or may not be a property. It may be another a different method that just returns a value. It doesn't matter. You don't have to think of it just as it must be a property. And then, of course, it gets a result back, and you can check that. Again, this is kind of like the next level up, the object-oriented version should be no problem. Let's get more interesting. This is where things start to stop people. What do you do when your test is talking to your SUT, but it is talking to something else? Something else. This is a little abstract. Let's make this a little more concrete. Let's say that we have the table that places an order to the waiter. You go into a restaurant, you sit down, you give your order to the waiter. You most likely do not know who the cook is. You will never see the cook. It's just kind of magic happens here, and eventually you get your meal, right? But of course, there are things taking place, the interaction between the waiter and the cook. Now, using this example, imagine we were needing to write a unit test for this. Can you think of why you might not want to use a real cook? Anybody? Why would you not want to use a real cook? It takes forever. It's slow. So if you watch a cooking show on TV, right, they make the things and they put it in the oven, and then from the other oven, it's already prepared, and voila, it's done. You don't spend time on the cooking show to actually do the cooking part. It's kind of like that. With a unit test, one of the most important things, the most important features of a unit test is that it must be fast. It must be blazingly fast, because you want 1,000 of these operating in a few seconds. And so using a real cook, not a good idea for a unit test. For a functional test, yes. Unit test, no. We really want to stick our fake cook in here somehow, that will sort of be already prepared with here is the meal. And if there was some way, if only there were some way, obviously in a test scenario, we would not have a real table. That's where the test sits, right? It places the order because we're testing the waiter. If the test could have knowledge in advance of the cook, well, then you have control. Then the test can place the order, and the waiter takes it, and then the test can sneak around and ask the cook, did you get my order? So now we are testing the waiter. Okay? So this is what we want to do. How do we do this? Here's another important term for you. Dependency injection. So the waiter has a dependency on the cook. We don't want the waiter to decide who the cook is. The waiter must give up that control in some way. Even if the waiter already has an idea of who the cook is, there needs to be a way to say, don't talk to him. I want you to talk, here, use this cook instead. Okay? So that's the basic idea behind dependency injection. And let's just dig down now one level deeper, and let me go into this in some detail. What are the different forms and styles of dependency injection? And I'm going to go over each of these. So let's start with an example. Let's say you have a method in a class, reminder ID, and it accesses the user defaults, and you want, of course, you're using standard user defaults. That's just the singleton that's out there. Here's the problem, right? Right there. Huh? How do we inject the fake cook here? That's the challenge, and this is where doing test-driven development necessarily changes your code. I think one of the problems that people have with TDD is they assume, I've written my code, now I want tests for it. Well, it doesn't work that way. I'm sorry. Not for unit testing. You have to make some changes to your code, and I recommend this book very highly. This is one of the books that started me on this journey. Working effectively with legacy code. The definition that Michael Feathers uses for legacy code is any code that doesn't have unit tests. This means any code that you just wrote is legacy if it does not have unit tests for it. So this is an important book because it answers the question, well, I don't want to make any changes because I might break something, but I need to make changes in order to make it testable. How do you solve this problem? That's where this book comes in. And it introduces an idea, a powerful idea of seams, a place along which you can cut to say, let's just slice here and put this other thing in. So the first technique for dependency injection I'm going to show you is called extract and override, or subclass and override. So here we are, we're back with our original method that's calling out to standard user defaults. All we need to do for extract and override is extract a method. So now you see the little bit of indirection that's happening. And now this gives us an opportunity. Now in my test class, I don't have to use the actual reminder ID. I can make a subclass called testable reminder ID. And it can override that special new method. Voila. Now, one of the dangers of this technique is that it is so easy. It is easy and powerful. It's a good way to start, but it can lead to fragile tests. You can imagine if you change your production code, that it may, like if you change the method that's being overridden to a different name and you didn't do so over on the other side, right? Things can break. It's a little bit risky, but this is especially powerful for legacy code because you don't have to change any signatures. Everything can stay as it is. So this is the first method. Here's another technique. Let's say you do have the control to change the signature. Perhaps you know where all the callers are and that's no problem. Or you're smart and you're using app code instead of Xcode. I highly recommend app code because it will go and find all the callers. Xcode claims to do the same thing, but it won't let you add an argument. App code, I can go in and say, change signature, I want a new argument, and it will go and change all the callers, and it will just pass in nil, everything will still work, and then I can find all those callers. So this is, you see what I did here. I just changed the signature from just plain next ID to next ID from user defaults, and I just pass in, please use these user defaults. This may look strange for this example. Imagine not user defaults, but something, a class of your own. Then it makes more sense. But it's very localized because it's at the method level, but it's still, you know, that's one way of doing it. Here's maybe a more powerful way. Property injection. So now you see instead of calling standard user defaults directly, it's calling self.userDefaults. This, of course, means I've introduced a property. An interesting property of properties is that you can construct the object and you may or may not set the property, right? That happens later after the object is made. So this is especially good for things, for dependencies that are optional, or a dependency for which you already have in mind a good default to use. And for example, with user defaults, it's not like you're going to write your own user defaults probably. You're just going to use apples, right? So anytime you call down to something at basically the Apple framework layer, you can provide your own getter for that property, which does lazy evaluation. So all it does is say, oh, it's looking at the backing instance variable and saying, is it set? If it's not set, I'll use the standard user defaults. If it is, fine, you know, I'll use what I already have. So in this way, Now we can, this is very powerful. This is getting better and better. But there's one that's may look clumsier, but is better than all. And that is constructor injection. I use the term constructor, even though in Objective-C, construction is really a two-phase thing, allocation and initialization. I'm afraid if I called this initializer injection, then you wouldn't find all the people who are talking out in other languages about TDD, about constructor injection, or I should say about dependency injection. So as you can see, all I've done is create an initializer init with user defaults and pass in the user defaults that to use, and it saves that in the instance variable, or if you like in your internal property. It doesn't matter either way, and then it uses that instead. The advantage of constructor injection, and the reason you should prefer this if possible, is that it makes the dependencies explicit. With property injection, you can kind of pretend that they're not there, which is good for certain things like standard Apple framework stuff. But when you start dealing with your own classes, then I encourage you to do prefer constructor injection. You may switch back and forth. I do sometimes. Engineering is all about trade-offs, right? But the advantage is that it makes it explicit so that when you create your class, when you instantiate it, an object of your class, you actually have to think, I need to provide this and this. And suddenly you have to think a little bit about those dependencies. So that's a quick overview. Dependency injection is not really, I'm showing it to you for the purposes of TDD, but it's not really a testing technique. It is an object-oriented design technique, and just doing this will improve your code and make things more powerful just by starting to use some dependency injection. It's just good OO. So quick recap of sort of this level of my talk. We've got extract and override, which is best for legacy code. I still use it even though sometimes even on my fresh code, just because I haven't quite figured out a good way yet to do the injection. So it's like, well, like for example, do I really want to inject a factory when something has to allocate something else? Maybe, maybe not. I may just want to call out the thing that instantiates the new object into a smaller method and override that. That's one time when I might use extract and override even on fresh code. So there's that. There's, of course, passing in your dependency as a new method argument. There's the property level, and there is the constructor or initializer level. There's one more that I didn't talk about or show you an example of, called ambient context, and that's if you're dealing with a singleton that you own and control. If you manage your own singleton for whatever reason, which may not be a good idea, or might be, but that's a different talk. If you have your own singleton, then before your test, you can say, hey, singleton, I want you to replace your guts. Right? Swap out your real thing. Here, take this instead, and there, now it's ready to go and to be talked to. You have to do some cleanup. It gets messy because after the test, you then need to eject that fake part and bring back its real guts. So it gets a little messy, but that's another technique. These are all described in this powerful book. Please don't be scared by the title. There is literature out there. You just may not find it if you start looking for iOS TDD, okay? Or iOS dependency injection. This is a fine book, probably the best on this topic. I highly recommend it. So now let's pop back up from dependency injection. Let's get back to interaction testing. So to remind you, in production code, you've got your SUT, and it'll be out talking to the real thing, whatever that thing is, the real cook, right? But for testing purposes, we want to substitute the fake thing. So now let's talk about what is that fake? What does that mean? What does that look like? What kinds of fakes are there? I'll show you another book that the second edition just came out. And again, don't be scared this time by the subtitle, Examples in C#. This is a very important book on the topic. One of the ways it's helped me is that if you look at, there's a big heavy book on design patterns for X-unit testing, and it goes into probably about, I don't know, at least 5 different types of fakes, and it can get very confusing about which is which and what, I don't know what to call it. The author of this book, Roy Osherov, simplified it to just 2. Stubs and mocks. So a stub is when the SUT is calling out to its fake dependency and probably getting a pre-canned result, right? I call this, and out comes the pre-prepared meal, and then the test, and doing that changes the state of the SUT in some way. The test can then ask the SUT, okay, I expect your state to be this or that, all right? As opposed to a mock. In the mock, the SUT is communicating with the fake object, but then the test runs around to the fake cook and says, did you get the order the way I expected you to get the order? So the difference between these two is which way is the test pointing. And you can have many stubs. If you have too many stubs, that's probably an indication, a code smell, that something is too complex. But you can have many stubs, but you should have only one mock at a time in any test. Great. So far, this is a bunch of hand waving. Let's get to some real networking, shall we? That's why you came here. The example I'm going to use, I'm just making a simple call using AF networking, just because that's the most popular way of doing networking, but this technique applies, it's just the example, okay? And you see, all it's doing is creating a request operation manager and then issuing a call to do a get. And there are 4 parameters. There's the actual URL for the get. There's a set of parameters that I don't care about for this example, so I just put in nil. And then 2 blocks, the success block and the failure block. The success block gets called if the get works and you get some data back, and the failure block is called if there's a problem. And the blocks each take, in this example, 2 arguments. I don't really care too much about the first one. The important part is in the second argument, where either for the success block, it's getting the actual response data or the error. So, what do we do with this? How do we start writing unit tests for something like this? Now, the first thing we want to do is inject that dependency, where you see right away, anytime you talk to a singleton, and you want to be able to ask sort of the fake cook, did you receive the order I expected? Then you'll need to be able to inject that. So using any of the methods, any of the techniques I showed you, you can inject the manager. The next thing we want to do is record the number of calls. The method is named get parameters success failure. So we want to see how many times was that called. Not just was it called, but because calling that more than once would be an error. in this case, right? So we want to see how many times was it called. It so happens that this method also has a return value. I'm not using it in my example, but just for the sake of completeness, you can imagine another test that does check the return value or does something with it. So we'll need some way to fake that out as acting as a stub. And then we want a way to capture the arguments. This here is acting as a mock. We want to get the URL, the parameters, the success block, and the failure block. So let's do that. Let's make a fake. I am the author of OC Hamcrest that helps with writing unit tests. I'm not talking about that. Also OC Makito, which helps with mocking, and I'm not going to talk about that either, because when you first start with mock objects, I encourage you not to use OC Makito or OC Mock or any other mocking framework. Start by hand. I think it's helpful to learn the mechanics of what's going on. Also, when a mocking framework, such as mine, doesn't do what you want it to do, people contacting me, I'm stuck, and I say, don't use it. Make your own. It's not hard. I'll show you how. So the first thing we do is I'll just create a new class called mock AF networking get, and you see it doesn't inherit from the actual manager class, it just inherits from NSObject, because in Objective-C, being a dynamic language, it doesn't matter what the class is as long as it answers the method. And so I copied and pasted the method signature in, so that's in place, and because it has a return value, I have to provide something, just return nil. Now this is just the stub just to get started. Now we're ready to record the number of calls. I'll do this with a simple integer property called call count, and you can see it just increments that property. In case we need a return value for stubbing, this is just another property. Instead of returning nil, it returns the fake return value. And if that's not been set, then it will be nil, so it's okay. And finally, we want to capture all the arguments, again, in a bunch of properties. One for the URL string, for the parameters, and for the two blocks. And all it does is grab them. There, we've got our fake. Now what do we do with it? Here's a starter test. Just to make sure that it's invoking the method that we want. And just to remind you of the 3 steps of a unit test: arrange, act, and assert. Arrange is done in the first 2 lines. So you see I'm creating the mock getter, or the mock, my mock object, and then I'm injecting it using constructor injection into the SUT. So that's the arrange part. Act is actually calling the method that I want. And finally, the assertion is to ask mock get, what is your call count? I really expect that to be 1. All right? So that's just, with that, I know that I'm calling the right thing. And you can also start to sense that this is where testing can get fragile if you're not careful. And why, if you can avoid interaction testing, you're better off, but it's a powerful tool. Now, let's get to a better test. This is where things get fun. Let's simulate a JSON response. The first 2 lines of the arrange portion are the same. I'm just making the mock object again and injecting that. The act is a little different. The act portion is to call the method and then say, hey, mock object, you should have captured a success block. Let's pretend we got a success result. I'm going to call the success block directly and pass in 2 arguments. Again, I don't care about the first argument, so it's just nil. The second argument is some JSON that gets transformed into NS data. And so I say, if the name is Jon Reid, and let's pretend that was that's what we got back from the server. Now I can ask the SUT, hey, and your name should be Jon Reid now. Yes? Yes, okay. This is where TDD really pays off, because I am not making a real server call. I was actually writing tests like this on the airplane. I didn't need a network connection. It's super fast. There's no need to do asynchronous jibber jabber. It's just like, let's just pretend. Let's just pretend we got JSON response. Now, with this framework, you can start to imagine I can do all my JSON parsing code and have it done in a TDD fashion. You can test your error conditions without having to actually generate a real error condition, so which can be quite hard sometimes to have a real error condition. Make them up. Doesn't matter. So here are the two tests that we have so far. Fetch resources should call get, and fetch resources success should set name. And just to show you a little bit of the power of refactoring, refactoring applies not only to production code, but to test code. We have some duplication in here. I think you can spot it. It is in the first two lines, the arrange portion. Test code doesn't have to be as dry as DRY, don't repeat yourself. We can be a little bit relaxed on that, but still, try to keep your test code. Your test code is also your code. So you want to keep it as maintainable and readable as possible. So let's extract this out to the test fixture using standard XUnit style, where we bring those two variables into instance variables, and then we have a setup method and the teardown method. And setup is called before each test, teardown is called after each test. So the way the standards XUnit behavior is, it will instantiate a test class, it will call setup, then it will call whatever test method you have, then it will call teardown. Eventually your test class disappears and it starts all over again with something fresh to guarantee that nothing interferes with each other. Now you may wonder why I even have a teardown. The reason I am setting SUT to nil is to ensure its destruction inside of the test. Because from setup to teardown, it's all still sort of, any failure will be reported as a failure in that test. So if there's a problem in the destruction of the object, I want to know about it and not just have something weird go throw an exception some other time. So that's why I do that. So having moved this stuff up to what is called the test fixture, this simplifies the test code considerably. Now you can really start to read the first test in particular. Fetch resources, assert equal, call count should be 1. That doesn't get much simpler than that. The second test is simpler, but not simple enough for me. I would like to take another step and extract a helper method. Rather than having all my, you can imagine many tests that try different forms of JSON, different JSON content. And I don't want to be repeating these lines all the time. So instead, I extract a helper method that will transform the string into an SData, and it will take care of calling fetch resources, because that's not really what I'm doing. That's just sort of a pre-setup step to capture the call, the success block, so that it will be called, blah, blah, blah. Look what it does to the test. Look how readable that test is. I want you to imagine now, if you had a test like this for your JSON parsing, how hard would it be to write the second one? Very, very simple. You just do. This is the power of refactoring test code to make your tests expressive. Your tests should be simple, so simple that when they fail, you're not debugging. You just look at it and say, there's something wrong. Are the inputs correct? Does that match the assertion? Yes, yes, yes. So keep your code, your test code expressive by extracting methods. So that's it. Kind of recap is here are the steps involved in making a fake. You want to stub the method. You want to record the number of calls to the method of interest. You want to fake any return value, and you want to capture its arguments. Once you start doing this a couple times, then I think it would make sense to use a mocking framework to make that simpler for most things, although, again, you may still find times that it's just easier to make your own because, as you see, it's not that hard. And we covered dependency injection and its various forms as a object-oriented technique that happens to be useful for TDD. And we've got the 3 types of unit tests. So now, hopefully, you can at least start to imagine how to break the logjam of doing real-world unit testing. This is my final slide. I list for you the 3 books that I mentioned that I highly recommend. Finally, a plug for my blog, and that's where you can obviously find me on Twitter. And I neglected when I started my talk to say thank you so much to the conference organizers, and not just the organizers. Everyone has really made me feel very welcome. The Polish hospitality is wonderful. I'm just very glad to be here and to have spent this time with you. So now it's time for questions, if there are any. And we'll wait for, whoever's got the microphone has the power. Did you just turn it off?
Cool. I just wanted to ask, do you think one of the 3 tests, of the 3 types of tests is better? Does it lead to better code, for example, to mostly have return value tests or state tests? Or
Interaction tests, as I said, they can get fragile. But sometimes they're just necessary. If you can do something just by trying to reimagine how you might do either a return value test or a state test, then you'll be better off, just because it's just simpler. It doesn't have all this complex injection stuff. And consequently, it doesn't have the possibility that the fake and the real thing might diverge. That's the real danger with fakes. So if you can avoid it, yeah, but it is powerful and helpful.
Jon? Hi, Jon.
Hi.
Thank you for your talk. Have you tried any dependency injection frameworks, and what framework works for you?
So I have not, and I've preferred not to. So just because for so far it hasn't been that hard, and even so the dependency injection book, of course, it goes on in one section to describe DI frameworks for .NET. There are DI frameworks out there for Objective-C. I would avoid anything that requires XML specification. I don't know why you would want to do that. I'm not saying don't use it. I guess treat it kind of like the mock object framework, where you do it by hand at first until you feel the need because you're doing a whole bunch of repeated patterns throughout. Then discover the DI framework that you like, but not at first. Does that make sense? Okay.
Okay, so
Yeah, you're on.
does it work?
Yes.
The question is, should one definitely mock something like AF networking, or is it better to design your API in the way that you have a facade and then you just test the facade and don't even touch the network requests? And actually, could you advise some good practices, which things should be mocked and which things should not?
So yes, the facade pattern is very powerful. And instead of making a direct call to, say, AF networking, I do think it is more powerful to create your own networking facade that sits in the middle, and because that gives you the power to replace, replace what's doing the actual call. And so that's very powerful. But then how do you test that thing? How do you test your facade? At some point, I still want unit tests, even on my facades, that it's doing the right calls to AF networking. How deep does that go? I use TDD for almost everything, almost all my code, and sleep better for it at night. So, but I do recommend the power of creating a networking facade so that you have then the control to replace it.
The question was actually more about what's out. So you use TDD for almost everything. What's the other part?
So the question is, if I use TDD for almost everything, what's the other part? Drawing? I don't do TDD for drawing. I do write acceptance tests and stick them into as part of, usually as part of my unit tests if they're fast enough. And what I'll do for that is I'll make my drawing, drawing code just right so that everything looks right, and then I'll write a test that takes a screenshot of that and says that's gold, that's golden, and compare a rendered image against that, so that then I can then get back to my real goal, which is the ability to refactor. Functional testing is still important because with all these fakes and stuff, you're really testing at a low level, sort of each component is doing its job. It's still good to have tests that make sure that everything is working, but they don't have to be exhaustive. If you've done written a whole bunch of unit tests, then you don't need many functional tests. You just want to make sure that things are connected properly, that it's actually making a real server call at some point. Then you don't have to be exhaustive with that. There are more questions still. We're not getting you in the mic yet. I'll have to repeat everything you say for the recording, though.
Oh, okay. Sorry, now it's working.
There we go.
The generic question is like, how percentage of the method that you recommended need a unit test? Because you say like you want to test everything and makes you sleep better in the night, but for a real situation, like there's a trade-off, like the amount of the development work, comparing the time and resources. Is there any practice suggestions that a decent amount of unit test for, what percentage of your code or method that being written?
I'm used to seeing 90%
Okay.
on my code, in the 90s. Even with that, I have the ghost of Uncle Bob floating in my head saying, "Go for 100." And so then if I have time, I will go back and try to say, is there anything I can do? But that's not really, right? The goal is not high coverage, it's high confidence, which they sort of correlate and they sort of don't correlate. But with TDD, if you do stuff with TDD, you will pretty much automatically get high coverage numbers, preferably in the 90s.
How do you deal with deeply nested system hierarchies, for instance, when you want to test your custom gesture recognizer and you can't simply synthesize UI touches because they go through the system, and how do you deal with this kind of testing?
So I haven't actually done any gesture recognizers yet. My apps are very simple. But if we take something else like taps on a control, what I'll do is I don't need to synthesize a full user event, however Apple does that, and pass that into the actual thing. All I need to do, because I don't need to test Apple's code, right? It may have bugs, but that's not my job. My job is to test my code. So all I need to do is make sure that it's connected according to Apple's requirements, and then pretend that, well, in the case of, excuse me, an action connected to an outlet, once I write a test to that the outlet is connected to a specific action, then all I have to do is call that action myself. So I would look for ways, if they're not direct ways like that, to have a method that does the real work, then I would extract a method and say, oh, well, gesture recognizer, that's a little too hard for me. At that point, I might just give up for the time being and say, well, let me just extract the handler method and make that, expose that in some way so that my tests can pretend that everything happened. I hope that makes sense. So I don't need to test the full circuit through Apple's frameworks. I just need to make sure it's hooked up and that it will call back.
So I have a question about the UI testing, and actually your last answers partially answered my question, but I will ask, to what extent does it make sense to test the UI? I mean, especially if you have the FAT test in the project, because okay, there could be an incentive to go too far with the unit test for the UI, because it's better to use one methodology, one technology in the project rather than to make some redundancy.
So I don't know if this answers your question, but in my view controller tests, I am not like, unless something is really, really a requirement that it must be red, I won't test the color, because somebody, the product manager may say, oh, let's change that a little bit, or the designer may say, let's change that a little bit. Anything that might change quickly, I probably won't write UI tests against that UI, unless it's really nailed down. And even then, I might find a different way to express it, and certainly a different way to factor it. I don't know if that helps answer your question.
I'm also asking maybe going too far to test, for example, the application flow, but this is rather the
So how to test the application flow?
how to test, but where to know not to go too far, because if you write the functional test, the functional test will test this behavior anyway, so we'll have like double checks in the application.
Okay, so the question is sort of where's the boundary between unit testing and functional testing, especially with application flow. What I do is with my view controllers, I will do extract and override so that I can replace the navigation controller with a fake. And I will write a unit test that says when the user performs this action, I expect the push to happen, and it should go to this this type of view controller, and with these arguments, the push should happen. And other than that, I don't care. So that sort of that connects from A to B, and you can imagine another test that goes from that view controller to the next. To tell the truth, I need to beef up my functional testing side. I haven't done very much of it. So far, almost everything I do has been at the unit level, and I've gotten quite far with that.
More convenient.
It is very convenient. It's one of, again, the main distinction is that it's fast. With a functional test, it actually has to go through it. It has to make the changes to the UI. It has to call the real service. It's just too slow for refactoring, which is my main goal, because I want to make a change, hit Command U in Xcode, or in app code I will do Control R to run my tests, and I want results in seconds, so that I don't lose my flow of my thinking. That's my main goal and the reason I focus on unit tests. How are we on time?
The next is lunch, so I think we have time for any other questions.
All right. Last but not least.
Of course, if you want to go eat something.
Yeah. I have two questions. One is...
oh, you cheater.
So the first one is, in Objective-C, is it possible to write data-driven tests like in C# with attributes?
I haven't found anything to do that. So with data-driven tests, you might say, I want to run this test, maybe taking the JSON example. I want to run with this JSON and this JSON and this JSON, for example. And I haven't found anything yet that does that. I think that's an opportunity for some good tool writers out there. So I'm afraid the answer is no. I would like that. I think it would be very helpful.
Okay, so what's your workaround? More tests?
More tests, yeah. My workaround is simply to have more tests, but also to extract helper methods, so that, again, each test is very small. So I might just have one test that just calls off to this other helper with this data and assertion, and another and another and another. So that's the sad news, but it works.
And the second one, you mentioned certain tools, AppCode. Two of the tools you made, and are there any others you use for unit testing?
Not me personally, but I know that Kiwi is very popular because it's expressive, especially Kiwi's nested contexts. So it's kind of like having a setup inside of a setup inside of a setup. That can get ugly, and you have to be careful that your setup code in a regular XUnit style doesn't get too large, because it can get lost, because it's all implicit. You can lose your way. Kiwi is good on that front because it makes that more explicit. So that would be another testing framework I would encourage you to use. I think we're out of time, but I am around. I'm happy to talk with you. Happy to look over your projects if you want. Thank you again for coming and for your kind attention.